All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing our neural networks module. Let's have a look at what we went over tonight. Now, last night, if you recall, the last thing we left off at was the gradient descent, and tonight we're going to pick up where we left off. So the gradient descent is an algorithm for minimizing loss when training neural networks. And recall that loss refers to how bad our hypothesis function happens to be. That we can define certain loss functions that just give us a number for any particular hypothesis, saying how poorly does it model the data. How many examples does it get wrong? How are they worse or less bad as compared to other hypothesis functions that we might define? And this loss function is just a mathematical function. And when we have a mathematical function in calculus, what we can do is calculate something that's known as the gradient. We can think of the gradient as a slope, the direction the loss function is moving at any particular point. And what it is going to tell us is in which direction should we be moving the weights in order to minimize the amount of loss. And so generally speaking, we won't get into the calculus of it, but the high level idea for gradient descent, it's going to look like this. If we want to train a neural network, we'll go ahead and start just by choosing the weights randomly. Just pick random weights for all of the weights in the neural network. And then we'll use, sorry about that, let me fix this typo here. Then we'll use the input data that we have access to in order to train the network in order to figure out what the weight should be. So we'll repeat this process again and again. The first step is we're going to calculate the gradient based on all of the data points. So we'll look at all the data and figure out what the gradient is at the place where we currently are, the current setting of the weights, which means in which direction should we move the weights in order to minimize the total amount of loss in order to make our solution better. And once we've calculated that gradient, which direction we should move in a loss function, we can just update those weights according to the gradient. Take a small step in the direction of those weights in order to try and make our solution a little better. And the size of the step that we take that's going to vary, and we can choose that when we're training a particular neural network. But in short, the idea is going to be take all of the data points, figure out based on. Let's do that again. But in short, the idea is going to be take all of the data points, figure out based on those data points in which direction the weight should move, and then move the weights one small step in the direction. And if we repeat that process over and over again, adjusting the weights a little at a time, based on all of the data points, eventually we should end up with a pretty good solution to try and figure out this problem. And this is our gradient descent algorithm here. So we start with the random choice of weights. We repeat the process of calculating the gradient based on all of the data points, direction that will lead to the decrease in loss, and then update the weights according to the gradient. Now, I'm going to leave it there for the night, where we did take a lot more notes and we did end up going into the stochastic gradient descent, but I'm not going to dive into that right now. We will pick it up tomorrow, but of course I will keep you guys posted every step of the way. For now, this is the Python Papi. You guys stay Gucci.